Welcome to the lesson on solving equations in Swift Calcs. Swift Calcs has a built-in solver to help you find solutions to problems involving one or more equations. To access the solver, in the toolbox click the Solvers item and then click and drag the Solver tool onto your worksheet. From Math mode, you can use the keyboard shortcut Solve space to also add a solver to your worksheet. When the solver is added to your worksheet, you can choose between two solution modes, symbolic or a Newton-Raphson numeric solver. The symbolic solver attempts to solve an equation as you would on paper. Consider a simple expression. 3 plus x over 2 equals 5. To solve for x, you would first multiply both sides by 2, then subtract 3 from both sides to find that x equals 7. This is essentially what the symbolic solver is doing. The symbolic solver will provide answers that are mathematically exact, and if there is more than one solution, it will also provide all possible answers. For example, we will solve x squared equals 4 for x. The symbolic solver returns both negative 2 and 2, both solutions to this problem. To use the symbolic solver, we enter the equation we wish to solve into the equation box. In the next box, we enter the variable that we are solving for, here x. The solver box is designed to make logical sense when read aloud. Solve x squared equals 4 for x using the symbolic solver. The answer appears as an array with 2 and negative 2. I can store this result into a variable using the answer box at the start of the solver. Note that the symbolic solver can also solve for equations with variables. If I change this equation to x squared equals 4 minus y, the solver will update and y will be in the solution, since y is an unknown variable. The symbolic solver, however, is limited in its abilities because it can only solve equations where the variable for which you are solving can be algebraically isolated in the equation. Many equations you may wish to solve do not fall into this bucket. For example, let's define a function f of x equals to x squared minus 1. We will then try to solve for sin x equals to f of x for x. Attempting to solve this equation with the symbolic solver produces an immediate error, unable to isolate x. You may also get an undefined result error for different situations. In these cases, we can turn to the numeric solver. The numeric solver works differently than the symbolic solver. It takes an initial guess for s, and then updates and refines its guess using a Newton-Raphson style algorithm until it finds a value of x for which the equation is satisfied. This means the numeric solution will always return only the first answer it finds, even if more exist. I select the numeric solver from the drop-down in the solver item, and immediately the solver solves the equation. Also notice that when I change to the numeric solver, the solver item updates to also ask us for an initial guess. It defaults to 0, however we can change this guess if we have a better idea of the result. Providing a better guess speeds convergence of the solution, and it can also help pinpoint a solution of interest if multiple solutions exist to a problem. For example, here, perhaps I instead want a positive solution for x. I can change my initial guess to 1, and the numeric solver will find a different solution closer to this initial guess. Note that both solutions are correct. However, the solution that the solver returns is dependent upon the initial guess that I provide. The solver can also be used to solve systems of equations that have multiple variables. Let's return to the symbolic solver and solve a system of equations. The first equation I will enter is 2x plus 5y squared equal to 30. I can then click the Add Another Equation link to add another box. You can continue adding more equations this way for systems with many more equations, and you can click the small x next to any equation to remove it. For my next equation, I will type x minus y over 3 equal to 12. I am now solving for multiple variables, so I also need to update my variable list to a comma-separated value of x and y. The solver returns a matrix with my answer. Each row in the matrix represents a solution, with the first column being the x value and the second column being the y value. Because I use the symbolic solver, I am returned exact representations of the x and y values. I can switch the answer to approximate mode to see the numeric values. Similar to before, you can also solve systems of equations using the numeric solver. I will change the solver mode from symbolic to numeric using the pull-down. You'll note I immediately get an error stating my initial guess is invalid. Since I am solving for two variables, I need to update my initial guess to have two values as well, one for x and y, separated by a comma. Note that while changing a solver item around, errors such as these may appear from time to time, as Swift Calcs will attempt to recompute the answer any time a change is made. Often, you have completed one change, such as adding an equation, without completing others, such as updating the variable list, and the errors appear. Simply continue updating the solver item as you intended, and once all inputs in the solver block are correctly filled, the solver will compute as expected. Join us in our next lesson, where we will dive into the differential equation solver in Swift Calcs.